What is the average rate of change of the function f of x equals 2x squared plus 3 between intervals 1 and 3? All right, so average rate of change is the formula f of b minus f of a over b minus a. I will call you A and I will call you B. So if I wanted to find f of b, because I already have a and b, that's easy. If I wanted to find f of a, we'll go with alphabetical first. That would be me finding f of 1. So I replace f of x. Every x is going to be replaced with 1. So 2 times 1 squared plus 3. 2 times 1 squared is 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 is 5. F of b is going to have me replace every b with every x with a 3. So that's going to be f of 3 equals 2 times 3 squared plus 3. PEMDAS says 3 squared first. 2 times 3 squared is 2 times 9 plus 3. 2 times 9 is 18. And 18 plus 3 is 21. 9 plus 10. So let's plug all that stuff in. All right, f of b was 21 minus f of a, which is 5, all over b, which was 3, minus a, which is 1. 21 minus 5 is 16. 3 minus 1 is 2. And 16 over 2 is 8. So there you have it. The average rate of change between 1 and 3 of this quadratic right there is going to be 8. You're welcome. Using the interval x and x plus h, find the expression that represents the slope of the secant line. All right, so the slope of the secant line is just fancy talk for slope. So let's use the slope formula. The slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now in pre-calculus, and AP pre-calculus, you might view this as this differently, and this is how I'm going to view it. F of b minus f of a over b minus a. So yeah, I am treating this like the average rate of change. You would be my a, you would be my b. So if I wanted to find f of a would be me replacing every x with x, so nothing changes. But this would have me replace for f of b every x with x plus h, like so. So now I come back up here and say instead of f of b, let's plug in square root of x plus h, minus, instead of f of a, let's plug in the square root of x, all over b, which is x plus h, minus a, which is x. And if you're taking a look at this and saying, those parentheses aren't necessary, you're right. Let's get rid of them. And the only thing that really happens that we're going to care about is the fact that the x's in the denominator are going to cross out. So when all is said and done, we get the square root of x plus h minus the square root of x all over h. And that's how you do it. Using the graph, what is the average rate of change of g of t over the interval 0 to 5 days? All right, so I'm given the graph. Average rate of change is just fancy talk for slope. So you're talking about the rise over run, the change in y over the change in x. So what I do is I say, all right, well, from 0 to 5 is just that little chunk right there. I'm going to find my rise, which is up 1, 2, 3. The y values or the g of t values go up by 1 every time, and I run 5. So 3 over 5. Now the weirdness of this problem comes from the wording. My y values, my g of t values are actually at rate. So my 3 is going to represent centimeters per day, and my x values are days. So it's not 3/5 centimeters per day, it's 3/5 centimeters per day. But the fact that it's 3/5 is the dead giveaway. Yeah, that's it. That's how I do that problem. Pretty simple. Find the instantaneous rate of change of the function f of x equals x squared plus 3x at the point x equals 2. This is the formula for the instantaneous rate of change. You take the limit as h approaches 0 of f of x plus h minus f of x all over h. So what I need to do is I need to go over here and find out what f of x plus h is, and then what f of x is, which I already know. So let me write that out. F of x plus h has me taking f of x and replacing every x with parentheses x plus h. So x plus h squared plus 3 times x plus h. All right. X plus h squared is a perfect square trinomial. So you're thinking FOIL thoughts. X times x is x squared. X times h and x times h is 2xh. And then h squared is h squared. Here you distribute the 3, so plus 3x plus 3h. And that's what f of x plus h is. You now also have regular old f of x, which I'm just going to rewrite out for funsies, x squared plus 3x. Now that I have these two guys, I can go back to the formula and plug stuff in. So the limit as h approaches 0 of f of x plus h is going to be what I have here in blue, x squared plus 2xh plus h squared plus 3x plus 3h minus f of x, so minus parentheses x squared plus 3x. And that's all going to be over h. Now, the scary part so far is the fact that I have the limit as h approaches 0 and h in the denominator, and if I were to plug in 0, I would get, undefined. That's no good. So what I need to do is I need to hope that some magic happens, and magic will happen. If I were to distribute the negative, I now get x squared plus 2xh plus h squared plus 3x plus 3h, so nothing's happened. Distribute the negative, minus x squared minus 3x all over h. Stuff will disappear. Okay, you disappear, and you disappear. And that leaves me with the limit as h approaches 0 of 2xh plus h squared plus 3h all over h. Notice that everything has an h attached. So pull the h out on top. So the limit as h approaches 0 of h 2x plus h plus 3, don't anything else, that was a close one, all over h, the h is crossed out. Now things are great. Okay, I have the limit as h approaches 0 of 2x plus h plus 3. So when I plug in that h, or 0 for h, u will go away. And that leaves me with 2x plus 3. However, I'm not done. At the beginning of the problem, we cared about when x was equal to. So I'm going to take 2, substitute x with 2 plus 3. That's going to get me 4 plus 3. And after all is said and done, I get a big fat 7. So very hectic problem, but we did it. All right, you ready for a killer? Because this is going to be a rough one. What is the instantaneous rate of change of the function f of x equals the square root of x plus x squared at x equals 4? The formula for the instantaneous rate of change is the limit as h approaches 0 of f of x plus h minus f of x all over h. So what I need to do is I need to come over here and find out what f of x plus h is. So that involves me taking f of x and replacing every square root, or rather every x with x plus h. And so yeah, we do have a square root, that's where my mind went. And so we get the square root of x plus h, not much I can do there, plus x squared, which is going to be x plus h squared. Now again, not much I can do there, but what I can do with the second one is I can say that you are a perfect square trinomial, and you simplify out to x squared plus 2xh plus h squared. Okay? Foil it out, baby. Now the other guy, stuff you already know, f of x, we already know is root x plus x squared, nothing wacky happens. Now we take both of these guys and we replace both of those guys with these guys. So I have the limit as h approaches 0 of f of x plus h, which is going to be gross square root of x plus h plus x squared plus 2xh plus h squared, right? And then I'm going to subtract all of root x plus x squared. All of this is over h. Now the issue is when I have the limit as h approaches 0 and I only have h in the denominator, plugging in 0 is a no-go. So I'm hoping magical things happen, I'm hoping things disappear, and all that good stuff. First I have to distribute that negative. So I have the limit as h approaches 0 of the square root of x plus h plus x squared plus 2xh plus h squared minus root x minus x squared all over h. Now nothing special has happened yet except for the fact that u and u will disappear. So that leaves me with the limit as h approaches 0 of the square root of x plus h plus 2xh plus h squared minus root x all over h. Again, I can't plug in h. Okay, I can't plug in 0 for h because that'll make, the whole thing undefined. That's no good. But what I do notice is that u and u have an h attached. So what I can do is I can kind of move you guys to the side. So I will say the limit as h approaches 0, I can keep you two grouped together, and I'm going to do so with a little bit of space, and you'll see why. X plus h minus root x all over h. And I'm going to move you to the side and eliminate all of these h's. In fact, let me just show that step. There's no need for me to rush things. So 2, let me factor out an h. So h, 2x plus h all over h crosses out. And what I'm going to do while I'm over here is, the h on the bottom is still very problematic. What I'm going to do is I'm going to multiply the top and the bottom here by the conjugate of that guy, not friendly at all, x plus h in the root plus root x all over x plus h plus root x. Okay, so one step at a time. What that does for me here after I FOIL this out is I get root x plus h plus root x plus h, giving me x plus h, minus grossness plus the same grossness, so these guys will cancel out in the middle, and then minus x. And that's going to all be over h times the square root of x plus h plus the square root of x, right? And then this just becomes plus 2x plus h. Now all of this is still being taken with the limit as h approaches 0. Okay? So let me write that out, the limit as h approaches 0. You cancel out. Now all of a sudden I have h alone over h times stuff, and the h's cancel out. So I am left with the limit as h approaches 0 of 1, because again the x is canceled out, gone, and that left me with an h over h times stuff, so 1 over the square root of x plus h plus the square root of x plus 2x plus h. Now I can plug in my 0 and feel pretty good. Okay? So if I plug in my 0 for h, u will go away, and u will go away. And that leaves me with 1 over root x plus root x is 2 root x, and then plus 2x. Still not done yet, because x is 4. So now I have to replace x with 4. So that's 1 over 2 root 4 plus 2 times 4. Okay, in the limited space that I have, 1 over 2 root 4 is 1 over 2 times 2, which is 1/4, plus 2 times 4 is 8. So when all is said and done, we get 8 1/4. Tricky, 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 gross, tricky, gross. but that's how you do it.